Assalamu alaikum, my dear students. Welcome to online support program. Hope you are all fine and enjoying online support program classes. Here, your science teacher Miss Arooba Farooq from EPSEX Gujranwala Cantt with the lecture of week 7 grade 6 science. Unit 6 Elements and Compounds. As we have started this unit in week 6 and in week 7, we still continue this interesting unit. In previous week, most of the students have done a wonderful job. You have done your work very nicely and uploaded your assignments very good. Well done, my students. Keep it up. Recap. Before starting our today's lecture, let's have a recap. Pressure in gases. Gas pressure is caused when gas particles hit the walls of their container. The more often the particles hit the walls and the faster they are moving. I hope you have clear a concept about pressure in gases. Introduction about elements and compounds and a brief discussion about elements. As we know that element is a chemical substance and that cannot be broken down into anything simpler. Elements are made up of atoms and each atom contains only one kind of atom. I hope you will clear about this concept. Learning outcomes. Today's metals and non-metals on your textbook page 73, uses of elements on textbook page 74, what is an atom on textbook page 75. Students will be able to learn, define metals and non-metals, understand the physical properties of metals and non-metals, and difference between metals and non-metals, uses of elements in daily life, what is an atom, its types and structure. Metals and non-metals. Elements can be sorted into groups according to their properties. Are they dull or shiny? Are they liquid, solid or a gas? Probably the simplest way of classifying elements is by dividing them into metals and non-metals. Introduction. There are 118 elements known at present. All elements can broadly classified as metals and non-metals. A majority of elements are metals except mercury, which is liquid at room temperature. And interesting information, there are 22 non-metals, that is 10 solid, 1 liquid, that is bromine, and 11 gases. Remember that students, 1 liquid, that is bromine, non-metal. Bromine is a non-metal. Metals and non-metals. Metals. A material that is typically shiny, has high melting and boiling point, and a good conductor of electricity. For example, copper, tin, zinc, aluminium, nickel. Non-metals, a material that is typically gaseous, has a low melting and boiling point, not shiny, and a poor conductor of electricity. Non-metal is an opposite to metal. Non-metals, for example, sulfur, bromine, carbon, and oxygen. Did you know difference between metals and non-metals? As we have read in the previous classes, hard solids tense and feel heavy, shiny appearance when polished, high boiling point, difficult to melt, malleable. Remember that students, malleable means that can be easily bent. Good conductors of heat, good conductors of electricity, sonorous, that means make a ringing sound when hit, and non-metals that are opposite to metals, usually gases or solid which melt easily, not very dense, dull appearance, low boiling point, melt easily, brittle, poor heat conductors, that means good heat insulators, poor electrical conductors, that means good electrical insulators, not sonorous. Now, there is a video about properties of non-metals. Remember that physical properties of non-metals.
We learned 4 properties of metals in our earlier video. Can you name them for me? Metallic luster, malleability, ductility, and that they are hard. These were the 4 properties, right? Can you think of some more properties of metals? Metal utensils are used for cooking, aren't they? Why do you think they're used for this purpose? Which energy do we need to cook food? Heat energy. Correct. We need heat energy to cook food, and metal utensils are good conductors of heat. They help transfer heat evenly through the entire surface and provide even heating. No doubt, most metals are known to be good conductors of heat. Do you know the 2 best conductors of heat? They are silver and copper. 2 other metals like lead and mercury are comparatively poor conductors of heat. Electric wires were also made up of metals, right? Why is that? It's because they are good conductors of electricity too. If we have a battery and a bulb connected in a circuit with a metal wire, you will see that the bulb will glow when the switch is closed. And because they are good conductors of electricity, they are coated with rubber-like material. This rubber-like material acts as an insulator which protects us from being electrocuted if we touch the wire by mistake. Do you know any other property of metals? What happens when we strike a metal on a hard surface? Like utensils banging against the sink. Can you hear a sound produced by metal? Yes, this is another property of metals. We can call metals as sonorous, meaning they produce sound when hit against a hard surface. No doubt, school bells, church bells, or the bells in a temple are made up of metals. If these are the characteristics of metals, what do you think will be the characteristics of non-metals? In simple words, just the opposite of metals. In a nutshell, non-metals like carbon, iodine, or sulfur do not have luster. They do not shine and are brittle in nature. What do we mean by brittle? They cannot be beaten into sheets or wires, as most of them turn into powder when hit by a hard substance. Non-metals can also be gases like oxygen, hydrogen, or solids like carbon, sulfur, etc. Do you know of any non-metal in the liquid state?
We have discussed.
Bromine is the only non-metal which is in the liquid state. Non-metals do not conduct heat or electricity, and they do not produce that sound when hit against a hard surface. This means that they do not have the property of sonority. So isn't it easy and simple to differentiate between metals and non-metals only on the basis of their physical properties? Wait, but mercury is a metal in liquid state at room temperature, and bromine is a non-metal in a liquid state at room temperature. How do we differentiate between the two based on physical properties? We can say that all metals are solids at room temperature except mercury, and all non-metals are either solid or gaseous except bromine. Well, this is not it. There are a few more exceptions that break the physical appearance norms of metals and non-metals. For example, most metals have high melting point, which means that they need a large amount of heat to melt. But look at the 2 metals gallium and cesium. They melt when you keep them on your palm. We must say then that these 2 metals have a very low melting point. Look at another exception in non-metals. Iodine, for example, is a non-metal, but it has a property of the metals. Can you point out which property I'm talking about? Correct, the luster. Iodine has shine or luster, which is technically the property of metals. Take another example, carbon, for instance. What is carbon? Is it a metal or non-metal? Yes, carbon is a non-metal, but look at diamond or graphite. They all come from carbon. They are known as allotropes. The different forms in which carbon can exist are called its allotropes. Let us look at the allotrope diamond of carbon. It is known as the hardest substance and has an extremely high melting point and boiling point. Aren't these the properties of metals? But it is surprising that diamond is an allotrope of carbon, which is non-metal. Diamond too is a non-metal which strongly exhibits the properties of metals. Now that we know of so many exceptions, do you think it's easy to differentiate between metals and non-metals based on their physical properties? I doubt that, but don't worry. There is another way out of this. It is to differentiate the two based on their chemical properties. How is that done?
Now, here is a recap what we learned from the video. Properties of metals. Metals have luster, this means they are shiny. Ductile, metals can be drawn into wire. Metals have a high melting point, they are also very dense like osmium. Conductors, metals are good conductors of electricity and heat. Malleable, that means can be easily melt. Metals can be hammered into sheets. Now, properties of non-metals. Non-metals do not have luster, they are dull. Brittle, non-metals are brittle so they break easily. This means non-metals are not ductile or malleable. Non-metals have low density. They also have a low melting point. This is why they are poor conductors of heat and electricity. I hope now you have clear concepts about metals and non-metals, its difference and its physical properties. So, there is a question. Is it any method for testing whether an element is a metal or non-metal? Think about it. Yes, it is. An easy way of checking whether an element is a metal or a non-metal is to see if it conducts electricity. There is apparatus set to test materials: bulb, switch, battery and crocodile clips. You have placed in the between of these clips material that you want to test, and if the material is electricity, if the material is conductor, then it conducts electricity, and if the material is insulator, then it's not conduct electricity. That means bulb will not glow. And next topic is uses of elements. The many different properties of elements mean they can be put a great variety of uses in daily life. For example, liquid helium is a very cold, which makes it ideal for cooling the magnet in this medical scanner. Copper can be drawn out to make fine wires which conducts electricity. Silicon is used to make the silicon chips used in computers. The xenon in these car headlights glows brightly when electricity passes through it. The mercury in this thermometer is liquid at room temperature and expands evenly when heated. Chromium is a shiny, unreactive metal used on motor cars. What is an atom? Last topic of today's lecture. An atom is the smallest part of an element and can exist and also take part in a chemical reaction. So, as we have all know that atom is the smallest particle. Did you know the word atom comes from the Greek word atomos? This word means indivisible. That means cannot be divided, and electron move at speed of over 2 million meter per second. Types of atoms. Atoms are extremely small, for too small to see with an ordinary microscope. However, atoms are not all the small sizes, and all atoms apart from hydrogen are made from three even smaller particles called protons, neutrons, electrons. Protons, these have a positive charge. Neutrons, these have a no charge, and electrons, these have a negative charge. Each atom always have the same number of protons and electrons, making it electrically neutral. However, the number of neutrons may vary. And now here are some examples that how atoms can be drawn like this. The protons and neutrons are packed together in the center of atom. This is called nucleus. And the smaller electrons whiz around to nucleus in tiny orbits. They move so incredibly quickly that they turn into a bloody cloud. This is called electron cloud. Now there is an audio you have to understand very well. There are some examples: hydrogen, helium and lithium. As we can see, hydrogen is the simplest atom and it has only one proton and one electron. So there is only one electron and one proton. And in the helium, two protons and two electrons. So two proton signs on the cloud and two protons. Carbon atom, 6 protons, 6 neutrons and 6 electrons. And in lithium has 3 protons, 3 electrons and 4 neutrons. Now listen the audio.
Atoms are the fundamental unit of matter. They're made up of 3 types of subatomic particles: protons, which are positively charged, electrons, which are negatively charged, and neutrons, which have no charge. Protons and neutrons are located in the nucleus at the center of the atom, while the electrons orbit the nucleus. Let's take a quick look at an atom of carbon. Notice how the 6 protons and 6 neutrons reside inside the nucleus, while the electrons are shown in orbits surrounding the nucleus. The number of protons identifies the element. All carbon has 6 protons and therefore 6 electrons. However, there may be minor variations in the number of neutrons in atoms of an element. These variations are called isotopes. It's a little difficult to show the exact location of an electron. This is because electrons have almost no mass and orbit the nucleus of the atom at incredible speeds. Therefore, their precise location at any given moment can't be determined. For this reason, electrons are often shown as a negatively charged cloud around the nucleus. However, other diagrams show the electrons as existing in rings or orbitals. Orbitals are often used to illustrate the number of electrons at different energy states surrounding the nucleus. This is important because only the electrons at the highest energy states, or outermost orbital, participate in chemical reactions. These are called valence electrons, and they are involved in the formation of chemical bonds between atoms.
Recap of today's lecture. What we have learned: metals and non-metals, uses of elements, atoms and its types. Assignment of week 7th. Test yourself, page 71, question number 1, 2 and 3. Short questions related to this topic element. Remember that question number 1, 2 and 3, page 71. And next, test yourself, page 73, question number 1, 2, 3, 4. Short questions related to the topic metals and non-metals. Test yourself, page 75, question number 1, 2, 3, 4. Short question related to the topic uses of element, and exercise question number 4 and 5 on page 82. Short questions from the concepts of metals, question number 4, and atom, question number 5. Thank you, my dear students. Best of luck, my students. Solve assignment 7th of week 7th. Upload it on AIS or send email or WhatsApp. Thank you. Have a blessed day. Allah Hafiz.